talk about the application of distributed generation technology in power system. So we had introduction, then now is the application. So at the end of this actually chapter, you will be able to discuss about the distributed generation technologies. So does anybody can say what is the distributed generation technologies, not source? So if not, you will be able to explain at the end of this course, this chapter, and what is the actually application of this technology in power system, and what kind of technology are used for the integration of DG sources to the grid or different part of the grid. So because it also used for the microgrid, but microgrid can be isolated from the main grid. So again, get back to this technology define. What is the distributed generation technology? Distributed generation technology is the technology for providing electricity from a smaller scale energy close to the load center. So it can increase the reliability and security of the grid. So I feel that, Arya is feeling a little bit sleepy. Yeah, no? Okay, if you're not feeling sleepy, say that what is the meaning of the reliability and security and how it can increase the reliability and security of the system.
They are talking about the reliability, so they are saying that can we trust whatever the grid is for whatever the power supply should be going through the grid.
Okay.
Considering the security part is whatever the components we are going to use in the they are not damaged by the third party.
Exactly. Excellent. Yeah, I made a mistake. Yeah. So it increases reliability. So it means that if you have unreliable system network and you are going to work in hospital or some other places, instead of providing electricity from unreliable network, you can provide electricity for yourself from the reliable source. So it increases the reliability and security of the grid. Also is that it mentioned that increase the security of the grid, but it is also secure type of the sources because when we have high demand, we can shift the load from the grid to the load. So it provides actually somehow increase the security of the grid by reducing the possible actually damage or outage. But again, it can be also secure source of energy because we don't have transmission and distribution line. In fact, such an event that a tree fall down over the transmission or distribution line and outage happening in the middle of the surgery. So it affect this type of technology. Can be configured to match the customer demand. It means that if you increase or reduce the conversion, then it can be also matched with the demand. So if you increase the power, then you can also inject more power. If power is like a reactive power or harmonic loads, then you are not allowed to use actually main grid to support your load, but you can use it from the power distributed generation system. So just one example. Assuming you have a company, you have nonlinear loads, then this nonlinear load is a combination of active power, reactive power, and harmonic. But if you connect your load to the grid, then distribution company actually send the fine, and you should pay the penalty because you request reactive power. But with this technology, you can use this model. This is the grid, this is your load, and this is a converter can be connected to your load. So reactive power can be compensated by this DG source, and active power can be compensated by grid. So you can easily handle this problem. So we can use the different types of the energy sources: battery, fuel cell, super cap, or lithium ion, and wind, solar, anything that can provide electricity. We can use this technology, so it can reduce the necessity to build the new transmission line, because we can use the conventional transmission line and we can compensate the rest from the local power generation, and it reduces the carbon emission because we are using the renewable energy sources. It reduces the peak load because we can also provide the extra load from the DG, and then somehow reduce stress over the grid. It can improve the system efficiency because it's close to the load center and you have less losses. So this is just some example of this technology. So for example, for the hospital, we can use actually this standby or peak shaving devices. So what is the difference between a standby or peak shaving? So peak shaving it means that we reduce the dependency to the grid during the peak time and use this local generation. But the standby is for the time that grid is not reliable or we have outage, we can use it. So some sensitive loads that we need the high power quality, it can be used by this technology to provide the high quality power, because if you make a little bit actually disturbance, make a little bit I don't know, if you have a radar and then you have some interrupt and then it changed the actually signal we are sending to pilot, then it makes a big problem. So it can combine heat and power, so the efficiency goes beside the electricity. We can also provide the thermal, and also for the office building also it can be used as a standalone and peak shaving. And the main is the grid support. So what is the meaning of the grid support? We said that when we integrate renewable energy sources to the grid, it makes a lots of problem because we use the power electronic. But here mentioned grid support. It can provide supportive functionality for the grid. But what is the meaning of this supportive functionality? Any PhD student here? I'm not. Okay. Udaya? Mm-hmm. Yes. Yes. Yeah. Yeah. One is that we buy from the grid and then sell from the grid to the grid during the peak. But some other is that using this DG technology for regulation of the voltage and frequency. So when the system is unbalanced, then voltage is changing, frequency is changing, then we can provide the actual regulation for that one. We increase the required power. So sometimes we have the reactive power, reactive loads, then it somehow change the voltage stability of the system, but we can increase the injection of the reactive power from DG sources to the grid, and then we regulate the voltage. And in some cases, when we have the more active power, so it's like this one. I'm a main grid. I have a backpack, so I put some loads with me, and you increase more, and then I feel that I'm falling down. But Udaya is a DG. So he takes some part of actually this load, and then we go together. So it means that, then my frequency is balanced because DG take care of the some active power. And in some cases, when you have the nonlinear load, in fact, you provide the harmonic components, which has a lots of problem for the grid. But by providing the harmonic current components, so you can tune your controller in a way that just provide the harmonic of the load, and then rest of the power can be compensated by grid. So by this, you can actually reduce these disturbances and increase the quality of the system. So, but what is the structure? We talked too much about the DG, and we said that we integrate renewable energy, so it means that we have a renewable energy and ask him to inject the power to the grid. Is it that much easy, Arya? No? Why is not easy? Voltage level? Yeah, switching, yeah. It can be also, yeah. But switching is it's not that much complicated. If switching is the problem, I think that you change your career. Yeah. So, you're a PhD student, yeah? So switching shouldn't be any problem for you. And I'm pretty sure that it is not problem for you. Okay, so switching is not. Then, what? Synchronization. Yeah, it is good comment. Synchronization is the one thing, but you're an engineer, you're a smart, intelligent person, so I'm pretty sure that with the advanced control design, you can somehow synchronize your system with the power grid as smooth as possible. So, yeah. So, any other comments? Yeah. You have a guard and you're going to say something. Yeah. What? Stability. Stability is important, but when you talk about the stability, it can be stability of the converter between the generation to the grid, or stability of the grid. So if you have unstable conversion system, it impacts the grid negatively, and if you have unstable grid, it impacts the operation of the grids. But I'm pretty sure that you can find the solution for that. So any other comments? So the problem is that I cannot memorize your names. Okay. So sir, what is your name? Yes. Abdul. Oh, I can promise that I can actually memorize. Abdul, do you have any comments?
Sir, I think whatever renewables are connected in this architecture, renewables and renewable energy sources, the power generated by those sources should be at maximum level with respect to its rating and specification.
Yes. Yeah, this is also maximum power point tracking is also very important. But the question is that, is it really easy to provide electricity from renewable, or is it's not? Arya, you always are negative actually. By this attitude, you should go to, you can be like a prosecutor or judge or lawyer, something like this. Yeah, but not electrical. You should be. Is it really hard to provide electricity from renewable energy or not? Is easy. Provide the electricity from renewable energy. Easy.
The problem is type of variable.
Yeah, variable is the main challenging part. Yes. What? Unpredictable.
Consistency.
Harmonics is major challenge. This is correct also.
Dependency.
Dependency.
On the nature.
Dependency on environmental conditions.
Yeah, this is also one thing. So, yeah, storage.
Major stages in conversion from AC to DC, DC to AC. Many power conversions are required.
Yes, this is also okay. So it means that you are engineer, what you are commenting. Okay. So providing the electricity from renewable energy is not hard, but we cannot provide it by chance and say, okay, this is the turbine, we provide electricity, and that's all. Okay. We should be careful to provide actually what we need, not what we have, what we have available. So the prediction is one aspect that we should consider, that how much power can be provided from renewable energy sources. And the other thing is that we have a constraint from the grid and from interfacing system. So in this course, I promise you, if you listen, not like sleeping mode and sometimes actually indifferent, like ¿puedes hablar español? Besame mucho, this gentleman can actually. And different, you are here, but your mind is somewhere else. So, but if you listen well, I promise you, at least you can provide some signal from the converter, okay? But I'm saying that, we learn together, so I cannot jump from the basic to advanced. So we go one by one. So, when we have actually this type of technique, so the network is combination of three main parts. First is the grid, second is loads, and third is the DG system. So it should be balanced between these three parts. Anything happen in any of these sections, then the system will be unbalanced and the problem will be appear. Okay? So for this case, the main challenge is coming from the load side. Why? Because provider is the power grid, but load side are the normal people that just turn on something, turn it off, and don't care what is happening in the grid. So when we're talking about the power quality, we need high power quality. In fact, we need high voltage quality. Why? Because P or S is equal to V times to I. Voltage times to current. Voltage is with the provider, but current is the load side. So now this light is on, and in 10 seconds you can turn it off, so it means that you can reduce the load and turn on something else, then the current is always changing. But the responsibility for the provider is first to provide the required power with high voltage quality. So if someone asks you what is the power quality is voltage quality. Why? Because the customer, we have no control the customer. We should provide what they need. But the thing is important is the stable voltage and required current. Current can change, voltage cannot change. So high quality stable voltage means high power quality system. Anyway, so once a mismatch happens between the generation and consumption, then the converter should provide it. So this distributed generation technology is combination of the actual generation side, interfacing system. It can be multi-level converter, two-level converter, modular converter, any types of the converter. Something that converts DC to AC, okay, because we need the AC. So, converter, and then we have a filter and inject the high quality power to the system. But we need the power management and control system. Why? Because here is the DC system and here is the AC. And the AC can be 60 Hertz or 50 Hertz, 110 volt or 220 volt or 400 volt, 11 kilovolt, what. So you should provide control on this. So converter is like a computer. So you can turn it on, but as long as you don't know how to program, it doesn't provide anything. But as much as your program skill is more actually expert, you have a high skill, it means that you can actually program in more professional way, get more benefit, or what you are looking for can be handled by this. So as much as the controller is working better, it provide more services to the grid. So if, for example, the load is nonlinear, you can ask the converter just provide the active power, but in a smart way you can provide the non-linear part, because the non-linear cannot provided by the grid and it can be considered as a disturbance for the grid. So for this case, it is important that we know how to program the converter and somehow compensate or problem, provide a solution for the problem existed in the grid. So any comment, question, something like this? No? Yeah. Okay, good. So if now we are going to explain what is happening, we said that, if we are going to integrate renewable energy sources to the grid, we need the converter, we need to control the converter and provide required power to load side or to the grid. So when we are talking about the converter is some tools, okay? It's like a vehicle. You have a Mercedes-Benz and in your parking, but the problem is that you don't know how to drive. This is the problem. Is you have a converter and you don't know control it. It means that you have a Mercedes-Benz at home, but you don't know how to drive. So for this case, the core point of integration is control of the converter. You can easily buy the converter from market, but you cannot control it. So it provide anything. So in this case, we see that this is the most important part for the integration of renewable energy. So we need the source, we need the power electronic converter, and we can also need the controller for the provision of electricity for the grid or for the load side. So this is the general structure. That one is just this part is the system we have, but what is happening in reality? So we have a DC bus here. We have a multi-level converter, but doesn't matter, multi-level, two-level, it depends what is the voltage level and what is the power level. So we have actually this interfacing system. We have actually impedance here. It can be combination of the filter, transformer, impedance of the, then we have the equivalent RL here. And then we have a load, but why it's this shape? Because when you make the simulation, you are going to provide the non-linear. So if you put the R, it's just the sinusoidal load. But in reality, you have a non-linearity. So for this case, we provide this load like this one when you make the simulation. And this is the grid. And what is this? What? Filter? No. Source impedances. We call it impedance of the grid. So as much as the impedance of the grid is higher, the grid is more weak. Okay? So a strong grid has smaller impedance. Okay. So if we go a little bit with more detail, we see that we have a source here, we have interface converter here, we have a gate drive circuit here, and pulse with modulation here. So we make the actually measurement from the grid side, load side, and converter side, make the control loop here, then give the order to the converter to inject based on what we need, not what we can provide, okay? So is it clear for you, Arya? Come here to explain if it's clear for you. Yeah, you say yes. You always say no, but when you should say no, say the yes, yes. Okay, like this one, okay? I'm teacher, so I understand that sometimes you're pretending to say yes. Okay. But Honestly, is it clear? Don't shy. We are learning together, so it's not expecting you say yes. Udaya? Yes, okay. Should I ask a question from you? Okay, good. I'm not that much brave. Okay, so, but basically, to make the controller, it's like this one. You have a car, you have a driving license, you know how to drive, but this car is not that you had, this is a new car, so you need some information about the car. And you need some information about where you are going to drive. And you need information how much fuel you have in your car. So for this case, we need information about the fuel or about the source that we have. And then this is my car. I'm going to control it in a way to inject power from here to here. Okay? So what I need is that where or what is the level of the voltage that I'm going to synchron my converter with it. So we need the information from the grid. So we get the voltage sample from the voltage for the analyze, for the control design. We need the information from the load also, how much power I need. If my load is nonlinear, so I should get the sample to see that this is a linear, nonlinear is a big load, a small load, what is, so the information from the load is important also. And then we need also information from the grid. So if my load is 10 ampere after control, so the converter inject 10 ampere or 8 ampere. So if it inject 10 ampere, it means that my converter is working well. But if it is not injecting 10 ampere, it means that something is wrong. Okay? So we also should consider the DC voltage here. Why? Because we are going to provide the energy from renewable energy sources. And renewable energy sources, the nature is variable, okay? So if we have a turbulence in the DC side, then it provides actually transfer these disturbances to the AC side. So we need a regulation here. So make sure that the DC is stable for provision of the stable also AC side. So we need all this information in the control loop to provide the right order for the control of the converter for injection power from a renewable energy source to the power grid. So any questions so far? This is a 3-level converter, okay, so for this case, but doesn't matter, it's 3-level, 4-level. If it was 4-level, we had DC1, DC2, DC3, okay? So, but for a 3-level converter, the structure is like this one. We split the DC voltage to VDC over 2, VDC over 2. Yeah, then the importance of actually this topology is that when we split the DC voltage, so assuming that if we have a 2-level and the voltage is 6,000 VDC, so then VDC goes over the transistor, okay? So 6,000 drop over each transistor. But when we go 3-level, this 6,000 divided by 2. So the stress over the transistor is less, or we can increase the power to 12,000. So it means that we can increase the power of the input and inject more power to the grid. So this is why we use the multi-level converter. Multi-level converter has also some other benefit like less THT and this less harmonic, and also the filter is smaller, but probably is out of the, yeah. What? RST, which one? Okay, yeah, RST is phase, A, B, C, 1, 2, 3, RST, yeah. So, any other question? Arya? Yeah, you swear? Okay, so come here. Yeah, to explain everything. Yeah, yeah. Otherwise, look, you should invite for the dinner. This is not handling by. No, no, it's okay. So it seems that you got the point. Yeah. It was risky. Okay. I mean, the difference between Finnish and Indian is that when you ask the Finnish, they can easily say no. Did you get it? No. Okay, but Indian, yes. Did you get it? Yes. I had some interview with some Indian candidate. So I'm saying that my group already I have some of them, and I'm really happy with them. But some cases actually I see the CV, they mention everything. Then I ask something, I said that they have this background. But I ask that question, I see that no. But they never say no. Yeah. But don't be shy to say no, because here we are learning, okay? I'm not examiner, I'm your teacher. Okay. And I like you also. Yeah. You start taking a nap without actually shying, yeah, in the class. Okay, anyway. Any questions so far? Udaya? Okay. So now this is actually general, just a sample of the different applications. So you see that the nature of this technology is AC. The nature of this solar is DC. Fuel cell is DC. And micro turbine is AC. Energy storage is DC. And then we have also different types of the load. So if we are going to actually supply, we need some interfacing system. So we need a rectifier. We have a DSP controller to